Okay, in this video, I'm gonna do this problem that I've set up on my own, right? This is just to make it kind of interesting, I would say, but also relatable. Fine. This is a linear programming problem that I have here. This is for NCV Level 3. And what I like with linear programming here Level 3 is because if you compare it with the one done by NCV Level 4 students, um, the NCV Level 3 is much easier since you are given the constraints. But in Level 4, that's when you'll be given a scenario, and in that whole scenario that you're given, you'll have to make the constraints out of given quantities in the scenario case. Okay, fine. Here's one simple problem. It says, Baby D owns a small bakery and makes 2 types of cupcakes. These 2 types of cupcakes are, the first one is caramel flavored cupcakes, costing 5 rand each. And then the other is chocolate flavored cupcakes, costing 7 rand each, right? So, but also this is like a real life situation because linear programming helps us to solve real life problems. In fact, simple ones only. But yes, it says she has limited ingredients and baking time available each day. And that's true. You can't have excess ingredients, right? You'll have some limited ingredients. When it says limited, it normally refers to like whatever amount of ingredients that you have. They're still limited because they are not infinite. Like they are limited as they are, depending on how many ingredients you have. But fine, she has limited ingredients and baking time available each day. Now, let X be the number of caramel flavored cupcakes made per day, and Y be the number of chocolate flavored cupcakes made per day. The following constraints are given. It's 10x plus 15y less than 600. Normally, but you don't have to know this in level 3, but in level 4, you'd have to think of where does this come from. This normally says, in simple terms, if you think of it as time constraint. In other words, it takes 10 minutes to make one X. What is X? Caramel flavored cupcake. It takes 10 minutes to make one caramel cupcake, and then it takes 15 minutes to make one chocolate flavored cupcake. But you own, like the baby D in this case only has 600 minutes available to make all of these. Doesn't matter how many there are that she has to make. But fine, don't think much about that for now. Just take the constraints as they are, since you're still in level 3. Okay, this is 2x plus 3y less than 120, right? Y cannot be less than, no, y cannot be more than 40. In other words, it can be at most 40. It should be 40 or less. So in other words, she can't make 40 chocolate cupcakes per day. She can't make more than 40. 40 is the maximum number. She can't make more than 40. She also can't make less than 20. This might be due to demand from her customers. So you'd find that per day, at least she has to make at least 20 caramel cupcakes. Otherwise, her business wouldn't go well. You see. So also, even though she can't make less than 20, but she cannot make more than 60. In other words, she can make minimum 20 per day, somewhere about around 20. It can't be less. But she can also make more than 60 caramel cupcakes. This would be due to the ingredients available, right? Also, these are the obvious constraints, the non-negative. The number of things can never be negative. Like now, if you were to count something and say how many of these are there, you can't say -5 things. No. It should be a positive number. Just like in this case, remember X represents the number of. So, in other words, you can't have negative number of cupcakes. It wouldn't make sense. So now, when you have to draw the graph, this is where the problem starts now. You just simply have to draw these constraints as they are. I'm going to start with the simpler ones, right? X greater than 0, meaning, remember, from here to this side, it's X. So you don't have negatives going to the left. So everything from 0 to the side is considered when I check this constraint here, this one. Also, when you consider this one, Y from 0 being positive going upward, you don't consider the area below. So now, let's go to this one here. X should be less than 60. You simply have to draw a line at 60. a vertical line. X equals to 60 is always a vertical line. In fact, equations whereby you have x equals to something, they are all vertical lines. Let me try to be as accurate as I can. It can be here. Let me just draw it here like this. Crossing 60. This is a vertical line here. And when you draw it as a line, you say x equals to 60. This is x equals to 60. Yes, the inequality says x cannot be 60. In other words, you cannot jump further. We can't cross this 60 and then go further. It means x should be, the maximum should be 60. We consider the area that's from here to the left. So in other words, when you look at this and these two together so far, the area at which we're gonna play around, it starts from 0 up until 60. You can't cross further because now you are limited by this 60 now when you consider this. But also when you put this one, it says x can start from 20 minimum, not less than 20. So what do? We no longer consider this one. We have to consider this. So now we have to draw a line at 20, a vertical line. Remember the x equations, x equals to something without having y. It's automatically a vertical line, x equals to 20. So now the area that I'm gonna be in now starts here up until here. No longer this side. This side is disregarded. But also, let's look at this one here. Y should be less than 40. In other words, the number of chocolate cupcakes should be less than 4. Should be not less than 40. Let me say 40 or less. Not more than 40, right? So now we're going to draw a horizontal line. Because now it's no longer dealing with x, it's y. So you're going to draw y equals to 40. It's a horizontal line. Right? Somewhere here it crosses. It crosses here. So now y cannot be more than 40. It's 40 or less. So my area now it's inside this rectangle here. But I'm not done. I still have to draw these two. Now to draw these two, it's quite easy. You know what you should do? You have to just draw, you have to find the intercept only. In other words, when I want an x-intercept of this line, you put y to be 0. This 3y will be 0. So you just throw it away. So you have something like 2x equals to 120. But we want to solve for x. So in other words, when you solve this, you say, you find the intercept first, right? I'm going to bring another paper on the side. This is a side note. This is 2x plus 3y. What is it? Less than or equals to 120. This way, right? If you want to find x-intercept of this, what do? You put y to be 0, right? So when you put y to be 0, you just, here, you put y 0 as 0 here. And then this 3y is going to be 0. You just remain with 2x. Remember, I treat it as an equation, 120. So solving for x is 120 over 2, which is 60. So now I know, okay, the x-intercept of that line is x equals to 60. Here, this is the x-intercept. Also, to find the y-intercept on this same line, you say y-intercept, then you put x to be 0, right? So on this equation, when I put x to be 0, the whole of 2x is going to be 0. So you just remain with 3y equals to 120. But now I have to solve for y. Therefore, y is 120 divided by 3, which is 40. I come back here. So the y-intercept is this one here. So I'm going to draw a straight line that joins this 40 straight to 60, right? But now, to be as accurate as I can be, right? Remember now I'm not using a grid line or a grid graph. So I have to try to be as accurate as I can be. By the time it crosses this x equals to 20, that line, I just simply do this. I just simply go to the same equation. Remember now I'm trying to determine where will it be in terms of y when it crosses x equals to 20, right? So, but if you have a ruler and everything, just simply join these 2 points. That's how you draw the graph. Just going to place your ruler like this. And then, okay, like this. And then just draw. On your grid paper, it's going to be as accurate as it can be. So you just have to draw. Every time when you draw the graph of these constraints, especially the ones that have x and y, right? Remember these ones are just vertical lines, the x's, and then the y's are horizontal. But when you come to this, do the method that I've just shown you. Find the x-intercept, find the y-intercept. You have them, then join them once using your ruler, right? So the thing is, I don't have a ruler here with me right now, so I can just simply draw like this. I feel like I'm gonna draw something. You find it's no longer a straight line, you know. So this is what I'm gonna do. Don't mind this, but I'm just gonna do it quickly. I'm just gonna determine, okay, when it comes to this x equals to 20, how the y be, or what would be the value of y in that equation. So now I'm just gonna do this too, and in terms of x, I replace with 20. 3y is 120. Then this is 40, so 3y is 120 minus 40, right? So 3y is 80. So this is some funny value, so let me leave that, and then also go for 60. Let me see. Yeah, I think x equals to 60. That's where it will be 0 sharp. Okay, let me just try just to plot as I was doing. So this is how your straight line is gonna be. I tried. It's gonna cross some value there. I don't know what that value is, but for all I know is it's 80 divided by 3, as I've seen previously, that y value. Fine. So what does it mean now? Looking at this equation here, the reason now I'm considering the inequality. Remember when I've drawn this graph is simply 2x plus 3y is equals to 120. When you draw the graph, you put an equal sign. Just like here, I put equal signs. I didn't put these inequalities. Inequalities, you just have to read them off. Or what do they mean? Like on x equals to 60, this says x cannot be greater than 60. So it's 60 or less. So it means f starting from 60 and less. Even here, this sign means something of that value or less. So in other words, you're going to consider the part that's below that line. So now, remember I had considered this rectangle. Now, this part that's above this line falls away because I don't need it. It says it should be less than. So now I'm under this triangle here. I'm now left with this triangle. You can scrape off the other side. I'm left with this triangle. So now I have to draw this line as well. This one. Do you see this one? I'm going to do the same procedure again on the side. But remember, if you can see it, you don't have to do it on the side. You can just get it quickly. But I'm just going to do this just to show you how do I get those things. So it's 10x plus 15y less than or equal to 600. This way. Again, I'm going to do the same thing again. Finding the x-intercept. It's what? The x-intercept will be, you put y to be 0. So this is 10x plus 15 times 0 equal sign now 600. So this becomes 0. So it's 10x is 600. Therefore, x is 600 divided by 10 is 60. So now I know also on this line the x-intercept is 60. What will be a y-intercept now? You do the same thing. Y-intercept, you put x to be 0. So what do you remain with? When I put x here to be 0, this whole thing becomes 0. So I'm left with 15. Y is 600. So that means y is 600 divided by 15. What will it be? Okay, fine. 15 goes into 60 how many times? 4 times, right? So it's going to be something like 40. The answer is 40. I don't have a calculator next to me, but I can verify this. It should give me 600. 5 times 0 is 0. 5 times 4 is 20, but I put 0, 2 here. Then 0, 1 times 0 is 0. 1 times 4 is 4. 0, I add this now. 2 plus 4 is 6. Yes, it's correct. So it's 40. At y equals to 40. But it's the same line. You see? So in other words, this constraint and this one are kind of the same thing. So I don't have to draw it again. So that means this is my feasible region. This one here. This will be my feasible region. That triangle. Because I've considered everything to be greater than 20. The side. Remember when I started, I was having this rectangle. And then when I draw y is less than 40, I was remaining with this rectangle. But now when I put this x equals to 20 and then say x should be greater than 20, not anything less than 20. This side is not needed, so I was left with this rectangle. But when I draw this graph now, it says anything less than below this line. This line, if it was greater or equals to, I was going to consider anything above this line. So it says anything below, just like this one. Remember, this one's kind of the same equation, but it's less than. So now I'm only concentrating below the line. I don't need anything above inside that rectangle that I was left with. So this part falls away. My feasible region is this. So now question 2 says indicate feasible region in the normally this is like 1 mark question. So you just write FR here, or you can show with an arrow, and then you write feasible region. Then you're done. So now the other question is this one. This one you're going to draw a table. It says if profit objective function is given by p equals to 5x plus 7y. This 5 comes from the fact that, because this is basically how the profit is obtained. When you're selling, you're going to sell your X, which is caramel, with that 5 rand, as I said. It costs 5 rand. The Y, which is a chocolate flavored cupcake, costs 7 rand. So this is your profit function. Then determine the maximum profit she can make. So now you have to determine the maximum profit that baby D can make per day, right? So now what am I gonna do? Here I've drawn a lot of stuff this side. So you're just gonna make a rectangle like this. So this is number 3, a table, in fact. So on your table you're gonna use the points of your feasible region. How many points do you have? You have this. The corners of the feasible region is 1, 2. Remember this one is what? It's 20 in coordinates. And then the Y value is this. Somewhere here. It was 80 over 3. So it's 80 over 3. I don't know how much it is, but if I were to use my calculator here on the phone, let me check my other phone. This would be 80 divided by 3, somewhere around 26,667. So this is approximately 26,667, which makes sense below, because even here on the graphs less than 8 this way. And your other corner is this of this triangle. So you're going to compare all these corners. You're going to do this. You see? So now your first coordinate of the corner is what? Is this one here. It's 20, 0, this one. The X is 20, but the Y is 0. This is your first corner. The other corner is this one. Is 20, 80 over 3. The last one is this corner here. It's 60, 0. It's 60, 0. Now you're going to use your function. The profit function. It's 5x, your objective function, by the way. It's 5x plus 7y, right? So you're going to do this. You're going to say P equals to, for this point, remember the equation is 5 times x. What is x? Is 20, right? So it's 5 times 20 plus 7. What is y? 0 times 0. 5 times 20 is what? It's 100. 7 times 0 is 0. So this is 100 rands. Gives you 100 rands on that point. Now, you're coming to this coordinate here. P is 5. Again, you use the same function. 5 times what is x? 20. Plus 7 times what is y? 80 over 3. Now, what is it? I'm going to do this on the calculator. So it's 5 times 20. Already I know that it's 100. So plus 7 times 80 over 3. It gives me something like 286, remember in money I'm just going to use 2 decimal places, 67. So it's 286,67. So I'm going to do for this one as well. It's P equals to 5 times 60 plus 7 times 0. 5 times 60, that's 300, right? So 7 times 0 is 0. So here I'm getting 300. Then you compare this. Which one gives you more profit? Is this point, the last one, right? So you say therefore, when you answer this question, you say therefore she makes. Okay, if they say determine the maximum, because the question says if profit function is this, then determine the maximum profit she can make. You say therefore she makes a profit. No, a maximum. Specify a maximum. That's what they want. A maximum profit of 300. That's the maximum profit you can make per day. So this is a practical example to know if baby D knows exactly the ingredients that she have, and then also knows how much will one need, maybe the number of cups of this and this, she can actually make something like this. And then once she does that, she can solve this kind of problem. To know that she can never make a certain amount, more than that amount per day. So this is how you determine the maximum profit you can make per day. As long as you have the info of your ingredients and your available time and everything, you can solve a problem like this. So this is how we solve linear programming questions on NCV level 3, right? It's straightforward, and I think this video will make it easier for just to relate, So that's the maximum profit you can make, the 300. But if they said determine the number of whatever, caramel and chocolate cakes, the combination of such that you'll make the maximum profit. Therefore, you'll say if she sells 60, remember this is X, 60 caramel cupcakes and just 0 chocolate cakes, then she can make maximum profit. She can only make maximum profit in that way. So this is how you solve these problems. But other questions, depending on the constraints, right? Depending on these constraints, you can have constraints such that the shape won't be triangle, be some funny triangle, man, or not even a triangle, or some other polygon, like another shape of having like many corners. Yours is to ensure that where it joins, the coordinates. Remember, if you use a grid paper or a graph paper, you'll read off your coordinates, but again, the coordinates of the corners much easily. So in that way, you can point out, okay, what is that coordinate? What is that coordinate? What is that coordinate of your visible region, right? Then from then, that's when you can do the table thing that I just did to determine the maximum profit. And also, you have to be careful on how you read your constraints when you draw them. Remember, drawing things such as this one's X and Y's, use the X-intercept or intercept method and then just join them. But be careful on the signs. When it's less or equals to, it means below that line. When it says greater or equals to, above that line. The Y lines always are horizontal. Y equals to 40, like this. X lines, vertical. Now also read off saying, okay, if you have that vertical line, if it says X greater or equal to 20, meaning you're starting from 20 and above, not below. You disregard the one that's less than 20. Like, that's how you treat this question up until you can determine your feasible region. This will determine you to find the enclosed space or area, which is your feasible region, right? If you don't understand, just hit me up, especially if you try another question on your own and then just check up with me if you've done it well or not.